conducted early in calendar year 1971, included the design, fabrication, and test of a special warhead configuration for the BQM surface-to-surface missile. The warhead was of the fuel injection type and was designed to be accommodated within the BQM-34A airframe. The volume occupied by the warhead consisted of the battery compartment and the forwardmost fuel compartment. The warhead consisted of an integral fuel tank forward of a shaped charge explosive unit. The cone-shaped void was built into the fuel tank and positioned with its base concentric to the shaped charge hardware. Capacity of the tank was 90 pounds of JP5 fuel. The shaped charge section contained about 245 pounds of C3 explosive. The forward bulkhead consisted of 1/2 inch steel plate with a spherical section extending into the explosive volume. Assembly of the hardware allowed for a 1-inch air gap between the aft bulkhead of the fuel tank and the forward bulkhead of the explosive unit. The half-cylinder cross-section of the explosive unit was fitted with 2 linear-shaped charges which extended the full length along the bottom of the explosive section. Other than the forward bulkhead of the explosive unit, aluminum construction was used throughout. Upon detonation of the warhead, the spherical section in the steel plate produces a slug which is propelled through the cone-shaped void in the fuel tank. With an initial velocity of about 12,000 feet per second, the slug is an effective penetrator. The jet-like action created by the formation of the slug, together with its penetration of the target, results in rapid atomization and injection of fuel into the target. Ignition of this atomized fuel within the target volume constitutes the primary damage-producing mechanism. The linear-shaped charges are intended to supplement the primary damage mechanisms for those instances where the missile would impact the superstructure, with deck areas below the point of detonation. The fusing for the weapon system concept is the walleye fuse. Design investigations indicate that the walleye fusing system can be readily adapted to this warhead and vehicle. The target for this test was intended to simulate in full scale DE or DD type structure. The 20 by 20 by 40 foot target was constructed at the test site with 3/8 inch high tensile strength steel walls, top and bottom. All walls were reinforced with T-iron stiffeners spaced 21 inches apart. All seams were double welded inside and out. A center wall divided the 40-foot length into 2 equal volumes, equivalent to 2 B1 or B2 size engineering compartments. The target was positioned at the end of the test track so that the test vehicle would impact the end face of the structure with a 15-degree obliquity. Warhead triggering provided a 20-inch nose crush of the missile's fiberglass nose before warhead detonation. This resulted in a 2-foot standoff for the warhead. The dynamic test of the BQM SSM warhead concept was conducted on 1 March 1971. The prototype warhead was installed in an expended but reasonably complete BQM-34A fuselage, which was in turn mounted on an undercarriage. By removing the BQM-34A turbojet engine, the total weight of the test vehicle closely approached the anticipated weight of the BQM SSM, with most of its fuel expended, approximately 1,700 pounds. The test sled's rocket motors propelled the vehicle off the end of the track and into the target at a speed of 400 knots. The design and test efforts summarized in this film report have demonstrated the feasibility of employing an internal warhead in the BQM SSM. The test effort has also demonstrated the effectiveness of this particular warhead design and configuration.